Well, dear students, I hope you have watched the videos on interference of light. And the interference of light is the result of superposition of two light waves. And I told you clearly that light wave are electromagnetic wave in nature, and it is the electric field vector of EM waves which produce sensation of sight in case of visible light only. You have learnt the chapter of EM waves. If you have not, if you have forgotten, please revise that chapter. I have mentioned good properties of electromagnetic wave which we need. Electric field vector produce sensation of sight, and due to superposition of two waves we get interference. I have derived certain facts. So before doing the question for competitive exam here and others, again I want to give the tips of the derivations done about interference of light. So first of all, we have derived if y1 equal to a1 sin omega t और y1 equal to a1 cos omega t, एक ही बात है दोनों, and y2 equal to a2 sin omega t plus phi, and here y2 equal to a2 cos omega t plus phi. If these two waves superimpose, we get resultant wave as sum of the two, vector sum. And while deriving, you can see the derivation of these. So we got the intensity of wave as k bracket a1 square plus a2 square plus 2a1 a2 cos phi. The same in this case. A1, A2 are the amplitude. This A1, A2 are the amplitude of electric field vector. In fact, in EM wave, we have used vector E is equal to E0 sin omega t minus kx or j cap, like this. Here I have taken omega t, I have taken let x equal to 0. These two waves are superposing at origin. So this is the intensity. Now here if A1 is equal to A2 is equal to A, then we have got there I equal to 4 Ka square cos square phi upon 2. Now what is this phi there? It was phase difference between the wave, and phase difference means direction difference. If y1 is this way, I suppose y1 this way, then y2 is this way, and with the direction difference. Now if the two waves meet in same phase, if the two waves meet in same means y1 this way and y2 this way, then intensity will be maximum, and that maximum intensity you will get I equal to k bracket a1 square plus a2 square, sorry, that is a1 plus a2 whole square. Whether you use this, if you use this, then you will get 4k square, I maximum. It is I maximum, and I minimum here equal to k bracket a1 minus a2 whole square. Please remember these facts. And therefore I maximum upon I minimum. I maximum upon I minimum is a1 plus a2 whole square upon a1 plus a1 minus a2 whole square. A1, A2 are amplitude of wave. Now in Young experiment, how the amplitude can be seen. how we can increase or decrease the amplitude. Actually, in double slit experiment, these two slits S1, S2, if they are of same width, actually amplitude of wave determines the intensity of wave, and intensity of wave is the energy carried per unit area per unit time. So if W1 and W2 are the width of these two slits, so if W1 is equal to W2, then A1 is equal to A2. But W1 and W2 proportional intensity, यानी कि I1 upon I2 is equal to W1 upon W2 or equal to A1 square upon A2 square. Intensity of wave, I have told you, in case of mechanical wave or if here is a point source, please see the power of the source. It may be source of sound wave, may be source of light wave. Point P is the source of light wave, or if it is sound source, intensity and distance R, I will be power upon 4 pi R. So this is one thing, whether it is source of light or source of sound. At distance R is this, because intensity power means energy per second per unit area. This will be the area through which it will pass. So divided by 4 pi square. And in case of mechanical or elastic wave, intensity by 2 pi square n square a square rho c. Here c is the velocity of wave, rho density of medium. Density of medium, A amplitude and frequency. So in interference we take the wave of same frequency, so frequency constant, density constant in case of sound wave. And this whole thing, this part we call energy density of wave. Energy density into C. So intensity of light wave are electromagnetic wave, and it is the electric field vector. It is the electric field vector which produce sensation site. So intensity of, again, that is half epsilon 0 E0 square into C. So in a given medium, epsilon constant, C constant, यानी कि I proportional to E0 square. I have treated here E0 in place of, I have written A1, A2 for two waves, because it is not easy to write. Then we derive the maximum minimum, and if these are two sources S1, S2 emitting light in same phase, and the wave meet here, this point O equidistant, so there is a relation delta phi equal to 2 pi upon lambda into delta x. इसको जरूर पढ़ना है आपने. I'm revising in brief. Delta x कहलाता है path difference. This is phase difference, lambda wavelength. If there is another point P here, there is point P where this S2P longer than S1P, or P may be this side also, on both sides. So if delta x means path difference, this one, is equal to n lambda. So delta phi will be 2n pi, and phase difference of even multiple pi. Phase difference of even multiple pi means same phase. And if delta x is equal to 2n plus 1 lambda by 2, odd multiple, n की value 0, 1, 2, 3. Or you can take minus also, but 2n minus with the n value will be taken from 1. Then delta phi will be n pi, odd multiple of pi. Actually pi means 180 degree. देखो अपोजिट फेज का मतलब क्या होगा, मैंने बता देना कि ये हमारा ये y1 और y2 है, ये इनके बीच का एंगल ये फाई है। अगर वो जीरो हो, ये घूम के जीरो हो जाए या फिर ये आ जाए, तो फेज डिफरेंस 0, 2 पाई 4 पाई मीन सेम फेज। अपोजिट फेज y1 दिस वे एंड y2 हियर दिस वे, तो नाउ इट इज 180, या घूम कर फिर 3 पाई फिर, तो देन इट इज ओड मल्टीपल ऑफ पाई। नहीं ये लिखा गया, सॉरी, डेल्टा फाइव भी 2n प्लस 1, सॉरी 2n प्लस 1 पाई अपोजिट फेज। तो व्हेन टू वे मीट अपोजिट फेज, तो ये रिलेशन भी याद रखने जरूरी है चैप्टर में जब न्यूमेरिकल होंगे। देन वी डिराइव पोजीशन ऑफ nth ब्राइट फ्रिंज या डिस्टेंस कह लो, डिस्टेंस ऑफ nth ब्राइट फ्रिंज फ्रॉम सेंट्रल मैक्सिमम। ये मैं डिवीजन क्योंकि भूल जाते हैं, तो दैट एक्शन वाज n lambda d upon d. Similarly, distance of mth dark, from central maximum. XM मैंने जानबूझ के m लिया है अलग अलग, 2m minus 1 lambda d upon 2d. Here m is equal to 1, 2, 3. Because in case of young experiment, central fringe bright, then we get first dark. If we put m equal to 1, we get position of first dark. Some people are writing here again n. Or they write 2n plus 1 also, lambda by 2, and they use n equal to 0. फिर गड़बड़ हो जाता सारा, सीक्वेंस ठीक नहीं है। Then fringe width हमारी आई थी w is equal to lambda capital D upon small d. Capital D distance of skin from to slit, small d distance. So width depend on small d, capital D and lambda. If you increase lambda, width will increase. If you decrease lambda, so our colors vary from violet to red. So if we use red color and violet color, so red color will have the fringe of larger width. Fringe width, whether bright or dark, same. There was one thing, angular position of nth bright fringe, that was n lambda upon d, and theta m, that was 2m minus 1 into lambda by 2d. What is theta m? Angular position. Actually, please don't mind, here the center, the screen, ये b है, ये small d है, और ये दो स्लिट S1 हैं, तो वो यहाँ पर जो पॉइंट बनता है ये थीटा लिया था हमने, ये इसकी पोजीशन बताता है थीटा। इट में भी डार्क फ्रिंज में भी ब्राइट, फॉर डार्क ब्राइट फ्रिंज थीटा n lambda d n lambda upon d, फॉर डार्क फ्रिंज वी राइट दिस। देन एंगुलर विड्थ बताई थी डेल्टा थीटा और लैम्डा बाई d. Now, if the apparatus is dipped in a liquid of index n, then you know velocity of light change, frequency does not change. Then fringe width will be lambda dash d upon d, and angular position theta n also, and lambda dash upon d, and so on. So these are some facts which will be now used in next video to obtain the solutions, and this chapter very important for every exam, whether it is plus 2 exam, CBSE exam, or it is NEET or JEE advanced, JEE mains, like that. कोई भी पेपर होगा, you will get a question from this chapter. It is simple one also, but actually so these things should be very clear. And first of all, you should have clear-cut idea of wave. What is wave? I keep on telling students wave. So some to get very easily, but some don't listen and keep on thinking at home. No. So wave, I told you, the variations of physical wave, the variation of physical quantity which transfer energy. In case of light wave, it is a varying electric, periodically varying. This equation E equal to E0 sin omega t minus kx. Here omega 2 pi upon t और k equal to 2 pi upon lambda. तो जब डिस्टेंस बदलेगा एक टाइम पर अलग अलग डिस्टेंस पर अलग अलग इलेक्ट्रिक फील्ड, अब वो टाइम वाइज बदलते रहते हैं. तो ना वेव इज नथिंग बट सिंपली the physical variation of some physical quantity which transfer energy. So now in the next video I will be telling you questions, numerical problem asked in competitive exam. Simple so I have done in one video from NCERT book, numerical from NCERT book. Please see the playlists to find and select the chapter, search chapter and then search playlist. And in playlist you get easily. Thank you.